Okay, let's start with a let statement, which is this right here. What variables are we going to use to represent what? So we're going to let x, y, and z represent three numbers, first, second, and third respectively, because we're talking about the first number, the second number, the third number. So first, second, third, x, y, z. In red, we have the sum of three numbers is 11. X plus y plus z equals 11. In blue, the sum of twice the first number is 2x. 3 times the second number would be 3y. 4 times the third would be 4z. The sum of those numbers, whatever they are, is 32. So sum means addition. And finally, in green, the difference between 3 times the first number and the second number is -2. So that difference means subtract. So there's 3 times the first number minus y equals -2. So there's your system. I labeled the equations A, B, and C for purposes of discussion. There's several different ways to solve this system. I'm going to make the assumption that you're using the addition elimination method. So what we want to do is take two different pairs of equations and eliminate the same variable. And then we'll be down to two equations and two unknowns. In this case, equation C is already missing the letter Z. So if I could eliminate Z from A and B, I'd have two equations containing X and Y, and I could solve that system. So here is a label that indicates what's happening. I'm going to eliminate Z from equations A and B. And I'm going to do that by multiplying the first equation by -4, so that I'll have opposites in front of the letter Z. So here's equation A multiplied every term by -4. Here's equation B recopied. When I add them together, equals added to equals are equal. I get -2x minus y equals -12. Of course, the z's disappear. So there's equation D. And now from equations C and D, I'm going to eliminate the y. Both equations are recopied here. And you can think of this in two ways. You can say I'm going to subtract this bottom equation from the top, or you can think I'm going to multiply every term of the second equation by -1 to get opposites in front of the letter y, whichever way you want to think of it. So 3x minus a -2x is 3x plus 2x or 5x. -2 minus a -12 is plus 10, so x equals 2. Notice -y minus a -y is 0. Y's disappear. Once you've got the value for x, you can choose any equation that has x and y in it. This looks like an easy one right here. Put 2 in for x, solve for y, which I've done right up here. If you picture this as 3x plus 2 equals y, that's what I did when I rewrote this. So y equals 8. And once you have what y is, you can substitute the known values of x and y into probably equation A is the easiest one. 2 plus 8 plus z equals 11. Z equals 1. There's your solution set right there, x, y, z. And you can double check, do these numbers add up to 11? Yes. Twice the first is 4. 3 times the second is 24, plus 4 is 28, plus 3 times the third, wait a minute, 4 times the third would be 4, that adds up to 32, and 3 times the first is 4, minus the second, -2. There you go, check. Okay, hope that helped. If you have any questions, post a comment.